Hello guys, I'm back again with another new video and another new solution. So in this video, I'll do this question: find the index of first occurrence in a string. So this is a very famous question of lead code, and I did this question in my last video, but this time I will tell you what is KMP algorithm by this question. So this question is a very this question is a very good example of using KMP algorithm, searching in a string. We use it for. So KMP. So its full form is Knuth-Morris-Pratt. So they were studying at Stanford, and in I think in 1978 they made this algorithm. So let's see what is this. So I'm taking a string, haystack string. So you know what is a question. So let me tell you question first. Haystack is sad but sad, and needle is sad. You have to search this needle inside haystack. So needle containing haystacks. Is this a haystack containing needle? So needle is what? Sad, and haystack sad but sad. So yes, it is containing sad. See this, and it is starting from 0th index. Though it is containing two sad, but first sad is starting from 0th index, and you have to return first occurrence. So first occurrence is 0. Yes, and see this lead code, and needle is Leto. So Leto is not present. Lead is present, but the whole needle is Leto, and it is not present inside lead code. So okay, so now let me tell you what is haystack. ONIUN. I am taking my example. Onions, sky. Okay, this is my haystack, and now I'm making my needle to uh, ONIUNS. So is this haystack first? I would like to tell you, is this haystack containing needle? So this haystack is ONIUN IUNSKY. So is it containing haystack needle? So ONIUNS. See, it is containing this. This is present inside this. So it means yes, we are doing it right. Okay, oh, not like that. Yes. So uh, first, I will tell you what is prefix. So, proper prefix. So, we will make LPS array for it. I will tell you what is LPS. First, let me tell you what is prefix. So, I'm writing only pre and or let me write prefix. Okay. So, prefix are what? O, comma N, O, comma ON, comma ONI, comma ONIO, comma ONI, sorry, ONION. These are the prefix, but this whole word ONIUNS is not a prefix. Only these five are prefix. And what are suffix? So if I write suffix here, SUFFIX, so suffix are what? Uh, S is a suffix, NS is a suffix, ONS is a suffix, yes, and IUNS is a suffix, and NIUNS is a suffix. So these all five are suffix, but ONIUNS is also not a suffix, not a proper suffix. So these are proper prefix and proper suffix, and we have to make an LPS array for needle. So LPS array, I'm writing it. Wait, let's see. We will Yes. So we will make an LPS array for this. For that, I will take this C LPS. Okay, and how? So see, first element of LPS array will always be 0, because if you check this O, it is not a prefix or a suffix. It is just a single letter. It is just a single letter. So we have to check with ON. Okay. So if I check with ON, are they matching? So no, they are not matching. So what we will do, we will just append 0 inside it. Okay. Then again, ONI. So are these ONI? No character is matching, and no, not character. Last one and first one are also not equal. So they will not match. 0. Again, ONIU. See, this O is equals to this O. Okay. So 1. Sorry, not 0. This time 1. This time 1 will come here. 1, comma, wait. 1, comma, uh, yes. So ONIO, and if I take this N also, N. So see this ON and ON, they both are common. So length of prefix is 2. And now ONS or ONI. So nothing is equal now. S and I are not equal, and if they are not equal, then it won't be any point in matching this. So see, this will my LPS array. Let me write it properly. Uh, this was looking untidy, that's why I removed it. And LPS array will be what? 0 comma 0 comma 0 comma 1 comma 2 comma 0. This will be my LPS array. See, till ONI, no one was matching. See this, till ONI, no one was matching. O is not a prefix, not a suffix, so that's why we appended 0 here. Okay, and then if I take O and N both combined, so O and N, no one is matching. If I take O and I, no one is matching, again 0. If I take O and I O, see this first O and last O, they are matching. If I take this O and I O N, okay, onion. So ON and ON are matching and they are 2. Yes, that's why we are appending 2 to this. And if I check this ONS, so if you want, you can make like this common prefix and common suffix. Only these one will match. See this. Inside proper prefix, I'm showing you this. See, ONION. Yes. So it was ONS. Yes, that's why. Okay. So if you take this much string ONION, you will see that this will be a common prefix, proper prefix, and this will also be a proper suffix. That's why we took it. So like this, we will make our array, and then what we will do, we will check how can we check this. So I'm telling you it how to do this. So see, we will check like this. We will have our j pointer at this, and we will have our I pointer at this position. So text block I is at this, I is at this. Okay, so now I and j are equal. A haystack of I and needle of j are equal. Yes, they are equal. So I plus plus and j plus plus. Okay, again they are equal. I plus plus and j plus plus. Again they are equal. So I plus plus and j plus plus. Now again they are equal. So again I plus plus and j plus plus. Again and they are equal. So now I plus plus and j plus plus. But now this time they are not equal. So what we will do then? So if they are not equal, we will move this j to LPS of. See, this is a catch here. This was this was a twist in their algorithm. We will make our j to j minus 1, LPS of j minus 1. J is equals to uh, LPS of j minus 1. Yes. So LPS of j is at fifth index right now. So LPS of 4. LPS of 4 is what? LPS of 4. Yes. And LPS of 4 is what? Which is equals to LPS of 4. So LPS of 4 is 0, 1, 2, 3, 4. LPS of 4 is 2. LPS of 4 uh, is equals to 2. This was LPS of 4. So J will go to 2, second index. Now it will check, are these equal? See this, I and I are equal. I is at I. Haystack of I is I. Needle of J is I. They are equal. Again, increase J, increase I. Okay. Now O and O are also equal. Increase J and increase I plus plus, J plus plus. So N and N are also equal. So again S and S. So now these are also equal. So again we will do it here, and I will come to K. So now see, J will go out of bound. Arrays till needle dot length. J will exceed needle dot length. Okay, and K will come at ninth index. Okay, this is ninth index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will return I minus needle dot length. Needle dot length is 6. I minus 6 is 9 minus 6 is 3. Yes. So 0, 1, 2, 3. See, this was third index. This was my third index. And see, my common onions is starting from here. This needle was starting from this index only. That was my whole algorithm. And now I'll write code for it. Let's see. So writing code is not easy for this. 0 and let j is equals to 1. And initially my LPS, as I said, LPS first letter will always be 0. You don't need to care about that. So not O, it's 0. So while I will use a while loop, j less than needle dot length. Sorry, my bad. Okay, so j less than needle dot length, and j less than needle dot length. And how we'll make this? We will do see what we will do. We will do I plus plus and C. I'm doing this onions. Let me make onions here. This was my needle. Okay, so if they are equal, so I will be here initially. I here, I, and J will be here. Okay, and see J here and I will be here. Okay, so are they equal? Not. So if they are not equal, if first I am writing for equal, if needle of I is equal to needle uh, of j, then what to do? I plus plus and LPS of j is equals to I. I will tell you why I'm doing this. And J plus plus. See this. I is at 0th index, yes, and J is 1th index. So see, suppose our J is here. Okay, take this example. So J is at J and I are equal right now. This if condition is happening right now. So I will do what? My LPS of J, LPS of J. So my LPS was this initially, but LPS of J is at which index? So J is at 4th index, yes. So LPS of J is equals to I, yes. So okay, suppose they are equal. So initially 0 comma 0 comma, this was the array initially, and now J is at 4th index, okay, and it is equals to I. So J is equals to, I will do I plus plus first, okay, I plus plus first. So I will come here, I is at 1th index, and then I'll push I value in this array. I value is 1, so I will push 1 into this array. That was my code. And if again see this, J will come here. Now I and J are again equal, so I will do first I plus plus. So I will come where? I will come at this 3rd index, and I'll push its value. Not this is not 3rd index, this is 2nd index, and I'll push its value to here. So 2 will come here, and at last if they are not matching, I will do 0. So in else case, else, see this. This is an important code. So else case we will have two conditions. What those two conditions are? Let me tell you. If I is equals to 0, so suppose if I is at 0, uh, sorry, my bad. If I is at 0, then we don't need to check. Are these we will just append 0 inside this. So LPS of J is equals to 0. Suppose if I is not 0, if I not equal to 0, or I can write else. If it not it is equals to 0, if it is not equal to 0, else. Because if it is equals to 0, it will fall in this if condition, else it will go in else condition only. So if it is not 0, then what we will do, we will see, this is also a catch here again. Suppose if I was here and it was not matching, so I will not append 0. Maybe previous element was matching, okay. So see what we will do. uh, See, if I was here and J was here, again our value should be 2, but how can I see that? Because this I and N are not matching. So I will make my I to here, and I will not do I minus minus. LPS of I, wait, I is not equal to I minus minus. We will not do I minus minus like this. We will do I is equals to LPS of I minus 1. I minus 1. Okay, I is what index? I is at 3rd index. Okay, I is at 3rd index. So LPS of 3 minus 1, 3 minus 1, yes. So LPS of 2, LPS of 2 is what? 0 1 2. So this will directly make my I to 0th index. LPS of 2 is 0, so this will make my I to 0th index, and now it will prevent us from again iterating. If it make our n, and this will also not match, so that's why it will make it to 0, suppose. Okay, so it will work like this. So in not in this example, because there will not be a condition where see, you might be thinking, if this will make this 0, so this O will not matching. See, if I make my I was here, okay, and if I make my I to here, so if you check this O N I O N, suppose, let me take this example also. If you check this O N I O N, two common prefix are there, okay. So I should be, I will not be here. I took this example, I have said the word suppose, but I will be here, I will not at I, okay. So I take this example, this is not a right example, because I will at n and j will also at n if I is at n in this example. So you can take another example that will in that you will understand more. So we'll do this, and see, now our while code ended, and let me show you how our LPS array will look. So, and see, j is equals to 0 and j plus plus. Yes. Okay. So now console dot log. Uh, what shall I log? Let me see. LPS. Yes, and let me run it. Though it will not give me a solution, this is not a right solution. So see, I'm just consoling it and seeing what is there in my screen. So see, LPS array. So see, sad word sad for sad. LPS array will be 0, comma 0. For see this for onions, 0, comma 0, comma 120. 0, comma 0, comma 0, comma 120. This was our LPS array, and that's how we made that. And see, if you do here I minus minus, so I'm not taking example. See, now we will write code for that KMP algorithm. So I is equals to 0 and j is equals to 0. Yes, j will also be 0. And while j less not j, I less than haystack dot length. Yes, and if hay haystack of I is equals to needle oh needle of j, then what we will do? I just do I plus plus and j plus plus. No worries. And if not, else. So again, in this else condition, we will have two conditions. What are those two conditions? So uh, let me see. If I not I, if j is at 0th index and they are not matching, so what we will do then? If j is at 0th index and they are not matching, suppose onions. See, I'm taking this example only. So if suppose I is at here and j is at 0th position, they are not matching. Just move I. They are not matching. Just move I. If they match, then we are doing this if condition. If they match, move j and I both. If they match, move j and I both like this. Okay. So if they are if j is at 0, just move I plus plus. Okay. Else what to do? Else yes. Else if they are not matching, so j is equals to LPS of uh, LPS of j minus 1. See, that's what I explained it to you. J is equals to LPS of j minus 1, LPS of 4, and then j went to I. That's how j went to I. 0, 1, 2. LPS of 4 was what? See this 0, 1, 2, 3, 4. This was LPS of this 2 was LPS of 4. This 2, my this 2 was the LPS of 4. So j, that's how j came to j came from this position, this s to here, and that's why we check that. So and this is my code, and see if this happened, and if j at the time j is equals to needle dot length. Okay, again length spelling is wrong, sorry. If j is here, then just written what, I minus the needle dot length. 9 minus 6 is 3. That's why I said this I will be at k. When I was explaining, I said I will be at k and j will be at this here. J will go out of bound 7, 6 out of bound. Okay, so last index is 5 and j will go at 6. So 9 minus 6 is 3 and we will return 3. So return needle dot length. Else suppose this whole while loop work and we didn't get any output, then return minus 1. Means we didn't get any output, no one is matching. So I'm running it and I'm seeing is there an error happening in this or not. So see, it is running and accepted, and if I submit it, it should be accepted. So all the test case are accepted though. Let me see if there is any error happening. See, this is working perfectly fine, and this time we did it in O of n. See, this code, this while loop is happening in see this in n dot length. If this is equals to m, if length of n is equals to m, so our first while loop will go O of m times. Yes, uh, O of m times, and then checking will happen in O of n times. So O of m plus n, and if both length are equal, suppose haystack is equals to needle dot length, then we will just do O of n, O of 2n, which is kind of O of n for our systems. Okay, so this whole program will work in O of n, and if you see this O of n, and are we using any extra space? So O of m plus n, yes, that's what I was saying. But if the in worst case it will be O of n. So you see, I was saying what I was saying. Are we using any extra space? Yes, we are using this LPS of 1, LPS array. So yes, we are using any extra space. So O of n is the space complexity, and let me yes, see, O of n is the space complexity. So that's what that was my solution for this. The point is here. You cannot do just I minus minus here. I minus minus. You have to do LPS of I minus 1, and here also j minus 1, LPS of j minus 1. This will protect you to for from repeated iterations. Okay, that's a catch here. Again, except this, the code is very easy. Nothing much in this code. So this was my solution. Thank you so much. And yes, we'll meet in another solution. Okay.